Okay guys, so the first question was a mechanics question, and this was looking at the first section about a tennis ball striking the racket. So in this case, it was asking me to find out what the average force was, so we're going to be using our impulse equation. So we're going to use force is equal to the change in momentum over the change in time. And in this case, my change of momentum, because it's starting at rest, okay, u is equal to 0, so I can just do my mv in this case. So I'm going to do 0.058 times 64, divided by the time. Being really careful, because time was 25 milliseconds. Okay, so again, if I plug all that into my equation, I got 148 newtons, but because my question is giving me everything to two sig figs, I should give mine to two significant figures at 150 newtons. Part B was asking us to calculate the average power. We had to be really careful with this. It wasn't asking for the power at the end, it was asking for the average power during the total amount of impact that was happening. Now there was two ways to do this. The first way, you could do your power equation is equal to the work that's been done over that time of impact divided by the time. In this case, the work being done was the change in the kinetic energy. Okay, so half mv squared divided by the time. So again, if I plug all those in, that gives me 4,751.36 watts, which, if again to two significant figures, is 4,800 watts. The second way that I could do this was I could have used my power is equal to the force times the velocity equation. Now this would be the power at that moment in velocity, and I'm trying to work out the average power, so I need to use the average velocity in this case. Now, because it's going from 0 to 64, I'm going to take my average velocity to just be half of the 64, so making it 32. If I plug that in, that gives me 4,736 watts, which is equal to 4,700 watts. Okay, again, given to two sig figs. And the IB, we're accepting both of those values for this, depending on which method you had done this. So be really careful, because a lot of people fell for that average power there. For question C, we've got some new data. We've got something that's being released at an angle. As soon as I see sort of angles and speeds, I'm already thinking SUVAT. I'm thinking about my SUVAT equations. And the nice thing to do is split your vertical and horizontal components onto the side so that you've got them there to kind of go back to. It should also be noting that in this question, we started also using three significant figures, so 2.80, 11.9, 0.910. So my answers at this point really probably should be to three significant figures. Okay, so the first one was then calculate the time it takes to reach the net. Now I could use different ways to do this. I actually chose to use my horizontal components here, so just speed, distance and time. Okay, because the horizontal velocity remains constant, I can just use my speed, distance, time equation there. Okay, so in this case I did distance divided by velocity. You got a mark for calculating horizontal velocity, so saying that it was 64 cos 7, okay, which gave me 0.187 seconds. The next part for D, okay, was then asking you to show that the tennis ball passes over the net, and this one was a little bit more tricky because we're trying to show a vertical height. Okay, so in this case, I'm going to be using my SUVAT equation to use my vertical components that I'm dealing with here. Okay, which is 64 sine 7, so I got one mark for recognizing my vertical component velocity. And I could say that the distance that it's travelled was 1.63 meters. Okay, now noting that if it's travelled 1.63 meters, that's how much this has travelled. What I actually need to look at though is that originally it was a height of 2.8. Okay, so it's 2.8, take away 1.63, which gives me 1.17 meters. Okay, so that's actually the height above the ground that it is. So it's dropped 163 from its 2.8, so it's 1.17 above the ground. Well, 1.17 is greater than 0.91. Okay, so it must pass over the net. Part E was asking you then to calculate the speed of the tennis ball as it strikes the ground. Now it's striking the ground at an angle, so what we needed to do was have the vertical and the horizontal and the vertical components of velocity. Now the horizontal component is always going to be 64 cos 7, but I want to find out what Vy is. So I'm going to use v squared is equal to u squared plus 2as, and I solved to get 10.759, and I left that in my calculator. To find out then what the resultant velocity was, I had to use Pythagoras' theorem, okay? And in this case, doing the root of 64 cos 7 squared plus 10.759 squared to give me a total velocity of 64.4 meters per second. Okay. The last part was a little bit tricky, and a lot of people found this one quite difficult, and it was a hard question. So for this, we've been told that the tennis ball strikes the ground. We've been given some different bits of information between a clay model and a glass model. Okay, basically during the contact they both slide. The sliding time is the same. Okay, so we have the same amount of sliding time through there, but we know the sliding friction force is greater for clay than grass. So the normal reaction force is the same for both surfaces as well. So what I've said here is I looked at it from the clay perspective. Okay, since friction is greater for clay, okay, the horizontal velocity has got to be smaller. So it's got less horizontal velocity. All right, so if we're thinking about horizontal velocity, this one's smaller for clay and it's larger for grass. Now the normal force is exactly the same, which tells me that their vertical velocity is also exactly the same. Okay, so if they've got an exact same vertical velocity there. Now we wanted to find out the angle. Okay, so at this point we're looking to see which angle would be greater. Well, the one that's got the smaller horizontal velocity is always going to have a greater angle. So the angle is greater for clay because it's got a smaller horizontal component. All right, the longer that horizontal component is, all right, the smaller that the angle will be. So you've got a mark for discussing the friction, saying that horizontal velocity is going to be smaller. You've got a mark for saying that the vertical velocity would be the same, and then a final mark for saying that the angle becomes greater on clay.